Welcome to this video lecture on the subject basic electrical and electronic circuits. In this we are going to discuss about basic electrical quantities. So what are the basic electrical quantities? Charge, current, voltage and power are the electrical quantities used in electronic circuits. So electricity is like a water hose. Let's take an analogy between electricity and water pipe. So when applying a pressure, the water flow is inside the water hose. So the voltage is like a pressure applied for the water. So current flow is related to the water flow in this hose. So size of the hose determines the water flow. So like that flow of electrical charges is the current through a wire, and resistance is the opposition provided to the current flow. So it is like a sand present in the water hose. So here the analogy between electricity and water hose is explained. So the voltage is the driving force for the current flow. First, let us discuss the electrical charge. So, the electrical charge is the fundamental property of a matter. So, it is present in every material. So, in an atom, so the charges present are positive and negative charges. Protons are the positive charges, electrons are the negative charges. So, the amount of electricity present in a body is defined by the electric charge. So, the unit of charge is the coulombs. So the next quantity we are going to discuss is the electrical current. So the current is the rate of flow of electric charges. So the unit of the electric current is the amperes. So the current flow in a wire can be DC or AC. So DC is the direct current, which is constant magnitude and direction. So the value of DC current is same throughout the entire time period. So the AC alternating current, which is the value of current varies with respect to time. So direct current is shown in this diagram in part A. So in part B is the sinusoidal current and C is the exponential current flow, where it is decreasing with respect to time, and damped sinusoidal current where the amplitude varies with respect to time period. So these are the oscillation. So these are the various types of current present in the circuit. Next is the voltage or potential difference. So potential is the work done per unit charge, where we move a charge between 2 points. So in a circuit, when the voltage is applied, so the charge flows from high potential to lower potential. So driving force that causes the current to flow in this circuit. Next is the power. So the power is the rate at which the electrical energy is consumed or generated. So or it can be rate at which the energy is transferred. So power is defined with respect to voltage and current. So V into I, or it can be given as V squared divided by R or I squared into R. So the power dissipation in a particular load is equal to I squared into R. So next, some other fundamental quantities are resistance. So here resistance provides the opposition to the flow of current in a circuit. So it is unit as ohms, and factors affecting the resistance value are length, area, material and temperature. So we can have the unique values for each resistance based on this resistor color coding, where first digit is the um, given in this tabulation, and second digit is also a value, and third one is the multiplier. For example, in this first color is the red one where the value is 2, second one is the black where the value is 0, and multiplier is green, so it is 5, so 10 power 5, and tolerance value of 10 percentage. So it gives the 2 mega ohms resistance value. And next is the capacitance. So capacitance is the defined as the ability or to store the electrical charge. So it consists of two metal plates in between dielectric. So the plates are charged with positive charges and negative charges. So the unit is farad. So in a capacitor, dielectric is used as the medium. So in the series capacitance, so the value is given by epsilon A by D. So increasing the distance will decrease the capacitance. And in parallel capacitor, where area is increasing, it increases the capacitance value. So capacitance is used in various filter circuits, and also it is used in rectifier circuits. Inductance. It is a property of a conducting material to oppose the change in current. So when the current is increasing, voltage is opposing that change is created by the magnetic field of the coil. So it stores energy in the form of magnetic field, and it produces the induced EMF when the current is changing. Let's take the assessment. So the rate of flow of electric charge is known as, options are voltage, current, resistance and power. So the rate of flow of electric charge is current. So the answer is B. What happens to the total resistance when resistors are connected in parallel? So the answer is, and option B, decreases. Thank you for listening this lecture.